Great, can you hear me okay? See if I think the mic's on enough, so this is good. Great, well, hi everyone, thanks for sticking around as the day gets towards the end. The goal of this presentation is really to talk about what it's like to develop an e-textile product, because I think when you're from a brand who's not familiar with the space, it can be very confusing what factors to look for, what a development process is like, what kind of talent you might want to look for. So we'll be going over some of those topics throughout the presentation. Perfect. So I actually included an introduction to e-textiles in this presentation. I think that it's something that you don't need because we've talked about it so much already. And just to give you a little more background about myself, I've been working in the e-textile space for about 5 years now. I'm very focused on mass manufacturing and production of electronic textile technologies. And recently, some of our work has been featured by Yahoo Finance and Wired Magazine and an Advanced Materials journal. And then some of the key items from this presentation will include a high-level philosophy, kind of that stack that Chris had mentioned earlier for working on developing e-textile products, language that can be used to develop and talk about e-textile components, a team breakdown for product development, and overview of existing testing groups and standards. So you already have this information, but e-textiles generally describe the integration of electronics and textile products. They can be done many different ways, as you've seen today. So this is an example of one that's printed directly onto spandex. That probably lasts nowhere near as long as the presentation we just heard from ACI. So there are lots of different methods and materials. There's this question of why e-textiles and what we can do with them. You've heard lots of use cases today as well, but just kind of harping on the idea that it's not just about consumer apparel, it's about all the places where textiles live, which is chairs, interiors, and I think that that's what makes the space so exciting, is that it's not just about clothing, it's about textiles as a core material. One of the core challenges in the e-textile space is merging together prototyping and production. So often it's very possible to build a prototype of something, but it's a huge challenge to get that prototype scaled because a lot of factories aren't set up for this kind of work. So similar to how Mine built their own factory in order to be set up to go from prototype to production, you can either build a vertically integrated supply chain and production process, or you can try and find these modular ways of piecing things together to make the technology scalable. Something that I like to talk about is that in a design process, especially for standard objects, a human-centered design process has become very popular. So it's this idea that the idea is the most challenging part of making a product, and the human-centered design process is all about developing an idea and testing it quickly. And kind of my argument, so it's the idea or the vision. And my argument is that in e-textiles, the vision isn't necessarily the hardest part. I think maybe you've experienced this too, that when you talk to someone about e-textiles, they're like, oh, my mom would use that for X. People have lots of ideas about what clothes could do if they had extra function. I think that the biggest challenges are funding, team, and product development. So making these products is a lot more expensive than making standard textile products. And especially, like when you talk to a luxury brand, for example, they're generally not expecting that. People send them free stuff because they're a luxury brand. And when you're working with e-textiles, you can't just take on tens of thousands of dollars to engineer and produce new boards for a prototype. You really need to be paying and working on that together. So cost is expensive. Team, you need an interdisciplinary team. And if you don't have that, you'll find that there are lots of pitfalls that are really easy to fall into or challenges that are hard to solve. And then on the product development side, you really need product development resources. So you need, let's say, injection molders or 3D printers in order to be able to make some of the industrial design parts of the e-textile, like that connector we saw from Lubrizol. Maybe you need a screen printing facility to print your conductive inks. So you need these new resources that are willing to work with new materials in order to make a prototype and then get that to production. In terms of the team that you might need, and sorry about the fonts, they got changed in PowerPoint, but in terms of the skills you might need, you often need a soft goods or industrial design person, somebody who's going to select fabrics and optimize for feel and design of the product. You'll probably need a material science engineering person if you're working with conductive inks, or if you're trying to solve problems that are chemical or water-based, like why washing is ruining your product. If it's not mechanical, it could be that water is causing corrosion. You'll need someone to help you solve that. And then electrical engineering to design all of the interconnect areas that bridge the hard-soft barrier, design standard electronics, and also design the printed areas of your electronics. And kind of the way that we think about this process is that because prototyping and production are often two different processes that don't always meet, we think of them as processes that need two different kinds of people to work on them. So the genesis or the prototyping process requires people who can quickly make things in-house, make a quick file, 3D print it, test it out, try again. And the production process requires DFM engineers, so design for manufacturing engineers, who can make really cheap parts for injection molding that will have the right overhangs. And I think that sometimes this can also be something that's challenging to approach in the space, because if you're hiring a DFM engineer specifically for prototyping, you're probably not getting the best iteration cycle you could. And if you're hiring like a creative tech prototyper for your scalable production, they probably don't have the QA and testing skills that you need to make a really good product to go to market. So now that we talked about team, we talked about the space, I think sometimes language around e-textiles can be very confusing. So I wanted to highlight the stack that we can use to talk about the pieces of an e-textile. And the reason why this can be valuable is that if you say something like, my e-textile is broken, nobody knows what's wrong. If you say something like, the insulation is delaminating, then everybody knows what's wrong, and that's something that you can fix. So because the language in this space is still developing, I think that it's helpful to have a stack to think about it with. So those items that we generally use are conductive patterning, which is the base layer. So somebody like Myatt uses knitting for conductive patterning. I think Functionware, who we'll hear from later, uses printing. We also heard ACI, they use a conductive ink. So there are different ways to make the conductive traces. There's also embedded components, which I'll get to later, integrated components, that insulation that I mentioned, and the integration method. So back to conductive patterning, I think a good way to think about this is that a brick of metal is not a circuit, just like a bag of flour is not a cupcake. It's like you kind of have to process these things to make them something that's really useful. And you have to pattern conductivity to make a circuit, which, as mentioned, has different ways of doing that. These are some different ways that electronics can be standardly made, like the flux PCB that's in the corner. Some circuits are printed onto Kapton or polyester, which is where printed electronics normally lies. Those things just have one direction of flux at a time. So when we get into wearable electronics, we're generally looking for multi-dimensional flux, which is why the space can be really challenging to work with. And then there's also things that can be in the textile space that are single power buses. So the item at the bottom is kind of like a USB cable in fabric form, but you can't pattern that into a heater. So in order to really get the most value of conductive patterning, you want to be able to pattern things in many different ways, not just have it be like a 4-bus wire or something that just goes linearly from one place to another. Well, these are some examples of patterning methods. There's knitting, there's embroidery, there's extrusion printing, there's screen printing, there's digital printing, so lots of different ways to try and pattern something that's conductive onto a soft, flexible surface that could be used for an e-textile. And then in terms of embedded components and integrated components, embedded components are typically something that you can pattern with the conductive trace itself. So it's something like making a resistive heater where all that is a conductive trace patterned to resist electricity and let off that extra heat. And then there's integrated components, which are pieces that you attach on top of the conductive traces. So it's like adding on an LED, adding on a PEC, adding on a battery pack. So those two items tend to have very different materialities. And just as an example, this is an example of a play mat that we make that's a drapable, flexible circuit. So the heating area is actually embedded. It's part of the main conductor. The lighting area is something that's been integrated in. So those are individual lights that we put into the circuit. And then the capacitive touch section is also embedded. So that's patterned in to read capacitive touch. Now, moving up in the stack to insulation. Insulation is, I think, an interesting and challenging topic because insulation can make or break a product. If something's really crunchy or crisp, that's often the insulation. And the reason why you want the insulation is to keep the conductive traces from touching somebody's skin, and I think also to keep your skin from touching the traces, because people sweat, there are oils, that can be really hard for chemicals. And so you want to have some sort of barrier there. But something that we've noticed is that people really don't like if your barrier is noisy, and plastic can be noisy. They also want it to be breathable. But if your barrier is breathable, then it's going to be porous, which also sometimes lets in water, doesn't really protect the circuitry as you'd want. So choosing a good insulation can be a challenge, but it's also a really important part of making an e-textile. And then integration is always a big one. So we saw that beautifully integrated jacket. Integration is just really thinking about how does this now become part of a soft good. As mentioned earlier, there are kind of two ways. One is you have a vertically integrated factory. Everything just has a step and it easily goes together. The second is trying to piece two things together. And there's where you really need to think about the integration process, because you don't want an apparel factory doing QA on your electronics. You don't want somebody sewing in or soldering a wire when they've never done that before. And alternatively, you just cannot send any soft good processes to an electronics factory. So you have to make those systems pretty modular unless you have a factory of your own. These are some teardowns that we did of products that exist on the market. I think they're interesting examples of what you can do. The heated jacket is basically a bunch of wires sewn into a jacket, which they built a custom factory for. On the other hand, there are these wires that have little overmolded wings on them that can go through a sewing machine, and that's kind of their way of getting around somebody having to work with wires who's not used to it. You just make it sewable. So there's really interesting things in teardowns that show how people are getting over these issues. Right, so on the testing side, I think one of the biggest challenges for understanding what test methods to use is what this image shows. So we have like a heating panel that we made on one side and a swatch of fabric on the other side. When you're testing textiles, as all of you know much better than I do, you generally test a swatch. A piece is enough to represent the whole system. For e-textiles, a piece is not enough to represent the whole system. So you often want to include the hard parts of the electronics when you're testing. Different parts of the circuit might be impacted differently. For example, if you have serpentine traces, those will stretch. If you have linear traces, those won't stretch. So if you're trying to understand if a whole unit is stretchable, you should probably test the whole unit, not just a square that you've cut out. So because of that difference, it can often be very hard to just apply existing standards to e-textiles. But some of the groups who are working very actively on these standards are IPC, who you heard from earlier today, ATCC, ASTM, and ISO. I put UL in there as well, because I think that there is some development in the space, but kind of tying into what UL currently has for safety. Most of their safety standards cover things like heating pads and heating blankets. So there's some level of soft goods e-textiles integration, but it's not really for everything. There's not something that you can use to just cover any battery like you can for UL battery standards. So there's some exciting opportunity to develop in that space. And then for performance, for wash testing, for example, there are things that we use like ATCC 135 or ATCC 61, and then just test for change in resistance or change in current pull instead of dimensional change or color change. So I believe ATCC is working on a specialized laundering standard, but until these come out, sometimes the best thing you can do is just take an existing standard, especially for textiles, and then understand what your main metric is, whether that's quality of data, change in resistance, whatever it may be, and then test for that each cycle, which sometimes you can get a third-party lab to do with you, even though it's not a real test for them. Great, and then at the end, there's the overview. So the main idea here is that I hope that some of these different pieces leave you with thoughts for going into a new e-textile project with more confidence. And a way that you can use all of these pieces together is to have the whole process in mind when you're beginning. So in the end, you're probably going to need to test and produce something. But in the beginning, when you're really thinking of the origin of the project, I think that it's very helpful to think immediately, of course, where's the funding going to come from? How am I going to get this interdisciplinary team together? What will I get from someone else? And what will I use my team for? Next, you want to identify the type of problem. So for some e-textiles, there's very hard material science problems. For some, they're very hard electrical problems. Just kind of understanding where the problem lies helps to form the team for the project. After that, you can start to identify where your biggest challenges are in the stack. So I think something that was interesting from the ACI presentation was that it sounds like there is a challenge in finding the right materials to laminate to. Knowing that, which is the integration process, is a really important part of the stack, you can understand where to spend the most time. Next, you want to understand the manufacturing implications, so of course just making sure something's going to be scalable. And then last is testing, and until there are lots of clear standards, you can always reference existing standards and at least use that as a baseline. So I think that's it for my presentation. I won't be able to be here for the Q&A, but this is my email, so if you have any questions, let me know, and thank you for your time.